sorry, I didn't hit record in time. So to go back, the first step when we are adding and subtracting mixed numbers is going to be to write them vertically, because technically we have two different place values. We have a whole number place value, and we have I told her not to, why do you think you can? And we have a fractional place value. Okay, so we want to start off by writing them vertically. Then our problem becomes finding the common denominator, or the LCM, least common multiple. That is the next step. We can't do any math without equivalent denominators. All right, step 3, as soon as we identify what our common denominator is to make equivalent fractions using the common denominator. After we've done that, and we now have fractions with common denominators, all we have to do is add or subtract. Steps 5 and 6 on your notes that I gave you are really the same in my opinion, and both of them can be kind of summarized with the word simplify. But for step 5, the first step in simplifying is to turn improper fractions into mixed numbers. And then the very, very last step is to simplify with the greatest common factor. So if I have the numbers 5 2/3 plus 2 4/8, the first thing that I want to do is write them vertically, line up the place values. So I have 5 2/3 plus 2 4/8. As soon as I get them lined up vertically, I need to find a common denominator by finding all the multiples of 3 and 8 and finding one they have in common. What are my multiples of 3? 3, 6, 9, 12, 15, 18, 21.
24.
Okay, we're going to stop there. What are my multiples of 8?
8, 16, 24.
Do they have one in common?
24.
So I'm going to make equivalent fractions with denominators of 24. So now I'm going to take both my fractions and change them into equivalent fractions with the denominator of 24. How do I get from 3 to 24?
8.
So what am I going to do with my numerator to make an equivalent fraction?
Multiply by 8.
What is 2 times 8?
16.
So my new fraction right here is 5 16 24ths. What do I multiply 8 by to get to 24?
3.
So what am I going to multiply my numerator by to make an equivalent fraction? Not 12. I multiply it by 3, which gets me 12.
Which is a half.
So now my equivalent fraction there is 2 12 24ths. So now I've written. Okay, but we don't want to simplify them. The whole point was that we just made common denominators. If we simplify them now, they're going to go to numbers without common denominators. So be very careful that we don't try to simplify while we're trying to make common denominators. That negates the purpose. So what is 16 plus 12?
28.
28. So I have 28 24ths. And what's 5 plus 2? 7. Now this is where they differentiate our simplifying step, because I now have a whole number and an improper fraction. So my next step is going to be to take this improper fraction and turn it into a mixed number. So I know that my numerator is bigger than my denominator, so I have at least one whole. How many wholes do I have if each of my wholes is every 24 pieces?
1.
I have 1 whole. How many pieces are left over?
4.
4. And the denominator stays the same. And now I need to add, we cannot forget about this whole number 7 that I originally had. So what do I have now? What's my answer I have so far? 8 and 4 24ths. And now I need to find the greatest common factor between 4 and 24 to simplify. What can 4 and 24 both be evenly divided by? What's a common factor they share? They don't, that's a multiple. You could do 2. Is that the greatest common factor? What is the greatest common factor? 4. So I'm going to choose to divide both them by 4 so I can simplify in one step. You could have chosen 2, and then you would have had to simplify it one more time. So what is 4 divided by 4?
1.
What's 24 divided by 4?
6.
The whole number stays the same. So my answer to that addition problem is now 8 and 1, 6. So when it comes to subtracting mixed numbers, there are 2 ways that you can do the problem. I'm going to show you both ways, and you can choose either method to use as your method, okay? Anytime we subtract, one of the problems becomes that we might have to start borrowing. And borrowing is difficult with fractions. It's not difficult when we're subtracting whole numbers, but it can be a little bit difficult with fractions. So I'm going to solve the problem 3 and 3/9 minus 1 and 2/3. I'm going to still follow all of these steps for the first time, okay? So first I want to write them vertically so I can make sure I'm lining up my place values. So I have 3 and 3/9 minus 1 and 2/3. Step 2, find the common denominator. What is a common multiple that 9 and 3 share? 9. So 3 and 3/9 gets to stay the same, but I need to change 2/3 into a fraction with a denominator of 9. What do you multiply 3 by to get to 9?
3.
Multiply your numerator by that same thing to make an equivalent fraction. 2 times 3 is?
69.
6/9. So now my new problem, if I was to rewrite it, would be 3 and 3/9 minus 1 and 6/9. Okay, well now I have a problem because I cannot take 6/9 away from 3/9. I don't have enough to take. This is where borrowing comes in. So now I'm on step 4 of doing the actual adding and subtracting. So if I have to borrow, I need to borrow from my whole number place value. So how many wholes do I have left? 2. So now I need to regroup that whole that I borrowed over to my fraction place value. But tell me this. How many do I regroup over here?
10.
Okay, so with whole numbers, we always regroup by tens. But with fractions, it's different. We regroup whatever our denominator is. Because basically what I'm doing is I'm taking one whole and I'm now writing it as a fraction with a denominator of 9. One whole written as a fraction with a denominator of 9 is 9/9. So instead of adding 10 when we regroup, I have to add 9 in this example. You always add whatever your denominator is because that's how many pieces are in the one whole that you just borrowed from. So this is why I'm talking about this is the more difficult way to subtract mixed numbers. It's the way I like, but you have to be very careful that anytime you regroup by whatever the denominator is. So the amount that you regroup every time, it's always going to represent one whole, but it's going to be shown in several different ways. So now I've got the fraction. I'm going to write it down here. 2, what's 3 plus 9?
12.
So now I have 2 and 12/9 minus 1 and 6/9. Now I can take 6 away from 12. Does that make sense? What's 12 minus 6?
6.
The denominator stays the
Same.
2 minus 1 is
1.
1. I don't have an improper fraction in my fraction place value. So now I can just find the greatest common factor and simplify. What's the greatest common factor for 6 and 9?
3.
So I'm going to divide both of those by 3. So I have 1 and
2/3.
very good, 1 and 2/3. Now I'm going to show you another way. So if the borrowing throws you off, you can choose to instead, I'm going to put it over here, you need to add a step anywhere within steps 1 through 3. So before you actually do your adding and subtracting anywhere in here, we want to turn mixed numbers
Oh yeah, I like that.
into improper fractions. That might lead to larger numbers that you're going to have to add and subtract, but you'll never have to borrow if you do that. So let's show you how you can do that. Okay, so I still have to follow all the same steps of finding common denominators, and then I can convert them into improper fractions and subtract them that way. So watch. If I know my common denominator is 9, like I said, 3 and 3/9 gets to stay. I want to change 2/3 into a fraction of the denominator of 9. I multiply 3 by 3. So I multiply the numerator by 3 to get 6/9. So now I have 3 and 3/9 minus 2 and 6/9. But now I want to use my option of making these into improper fractions. To go from a mixed number to an improper fraction, we want to make our mixed number mad.
Oh.
M stands for multiply. I want to multiply my denominator times my whole number, because in each one of those wholes I have 9 pieces. So what is 9 times 3?
18. 27.
27. Then I want to add that number that I get when I multiply to the numerator I already had. What's 27 plus 3? 30. So now I have just changed that mixed number. My denominator stays the same. So now I've got 39. I've made my mixed number mad and turned it into an improper fraction. So I made a mistake. This should be 1 and 2/3. And that should be 1. So 9 times 1 is 9. 9 plus 6 is 15. Okay. Now I've got the same problem that we had before, so we can prove that they are, in fact, going to be the same answer. What is 30 minus 15? 15/9. So I did not have to borrow to do this. And now all I have to do is turn my improper fraction into a mixed number by doing 15 divided by 9. How many groups of 9 are in 15?
1.
What's 1 times 9?
9.
15 minus 9 is?
6.
My remainder becomes my numerator. My denominator is my divisor. And what is a common factor that 6 and 9 share to simplify?
3.
3. So it becomes 1 and 2/3, which is exactly what we got when we did not turn them into improper fractions and just borrowed. So you can choose either method, okay?